I want to see, how many of you here actually use R? That's pretty good. Anybody here because this talk was labeled as about big data and they don't know anything about R? Good. Two good answers, thank you. So I'm going to talk about applying R in enterprise applications. And first I'll talk about why you might want to do this. And since you're here, you're part of these meetups, I'm sure you know many of these things. There's a lot of big data analytic challenges that are faced by large organizations. One challenge is simply collecting more and more data, and the expectation as you collect this data, you actually want to do something valuable with it. That might be obvious, but sometimes the focus is too much on collecting the data and not as much on actually getting some value out of it. How do you get value out of data? Well, there's multiple ways. One way is trying to get deeper insights into that data. An important way of doing that is with visualization. I'll be talking a little bit about how Spotfire helps visualize big data. And another way to do that is using more advanced analytics or machine learning or data science. Different people use different of those three terms, but all about getting deeper insights into your big data. And another way you might get value out of this big data is not only doing analytics on the data, but creating these insights, but putting these insights in the hands of more people, in the hands of people who are making decisions across your organization, expanding this capability to leverage these insights beyond the data scientists. And then another important point is making faster decisions, whether that's helping decision makers make their decisions faster, or whether it's automating decisions. Things like when someone visits your website or calls your call center, or a transaction is going on that might be fraudulent, automating some decision about how to handle those events. And finally, the goal of all this is being agile, is agile responses to emerging opportunities and threats, because not only do the answers constantly change, but the questions you want to ask constantly change. So it's important to have a dynamic environment that can change quickly. And there are many different ways to get from data to making a decision and taking an action. In the dark blue in the upper half, talks about what do the benefits the different tools and platforms provide for you. That many organizations really do descriptive analytics. They're looking at the data, and then it's dependent on someone who's kind of represented by the light green color to do the human heavy lifting, to do that interpretation, that analysis about what the tools are telling them, and then take some action based on that. More advanced analytics, predictive and prescriptive analytics, machine learning, those are the tools that help reduce some of that cognitive burden on someone to do that analysis, to do that judgment about what is the right decision to take and what's the action that you want to take. And again, you can think about prescriptive analytics falling into two buckets. Decision support, where you're providing the right answer for someone, how they should respond to a given opportunity or threat. Or decision automation, where you're taking that all the way to the point of having some system automatically decide of, I want to make this marketing offer, or I want to stop this fraudulent transaction, etc. And so advanced analytics and machine learning are all about helping deliver these smarter, faster decisions, reducing this cognitive burden for someone, for a human being to have to analyze what the tool is telling them, figure out what the right decision to take is. Now, for doing these sort of advanced analytics on big data, there are many options. I'll just cover a few of them here. H2O is a partner that we work with quite a bit. They're a great platform for building predictive models on big data that's sitting in Spark or Hadoop. And last I checked on the H2O website, there's maybe about 10 different predictive models that you can do on big data. Similarly, you can use MLlib in Spark to do predictive models on big data that's sitting in Spark. And last I checked, there was about 20 different types of models that you can do in the Spark environment. Then, of course, there's in-database algorithms, many different vendors, whether it's Vertica or SQL Server or Aster, etc. All provide a lot of in-database algorithms for doing this analysis on big data. And last I checked, it was somewhere around 10 to 20 models. It varies a lot based on vendors and how you count. And then, of course, many people use Python. Python is a great platform for data scientists. There's many different analytic methods that are available in Python. But it's not really designed for big data. And then there's R. And sounds like many of you are familiar with R already, which is great. So I won't spend too long on this, but as sounds like almost everybody in this room knows, R is the most popular and powerful language for data science, often called the lingua franca of data science. It's rapidly growing. Many people are using it, and more importantly, or just as importantly, what you can do with it is rapidly growing. There's almost 9,000 user-contributed packages on the main repository for R called CRAN, and this growth has been exponential over the last decade or so. And so you compare that 9,000 number to 10 or 20, and that's a big part of the reason why people want to use R for data science. And no, it's not a one-to-one correspondence. Many of these 9,000 packages might be slight variants on existing model types, but still this is a reflection of the richness of this environment for data science. And there's a vibrant R community that's out there. It's part of, of course, there's many different organizations, many different user groups around R. Most recently, the R Consortium was started about a year ago, founded by TIBCO and Microsoft and RStudio and a number of different vendors. So the R Consortium is focused around really providing support and helping the growth of the R community. If any of you work for organizations that use R extensively or integrate with R in your products, I encourage you to look at the R Consortium website. I've served on the board of the R Consortium, so you can talk to me as well. So we talked about analytic challenges, we talked about R, and since many of you are users of R, you know that you can use R to help address these big data analytic challenges. R is agile. It provides easy data prep, easy to prototype new models and analyses. And it has this huge array of analytic methods available, which means the best method, depending on your definition of best, is probably available to solve any given problem. And it's these 2 points, the agility and the vast array of methods that are available. This is why R is so popular. This is why people like to use R for data science. But R has its own challenges. One is performance. It was not really designed for streaming or for big data. It was designed as an analytic tool for statisticians. It's hard to use for a non-data scientist. So, it's not something that a business user is typically likely to use on their own. So you typically need to integrate it or wrap it in something else in order to make it available to a wider audience. And it's sometimes challenging to integrate these into enterprise applications, partly because of performance, partly because of commercial support for mission-critical applications, also partly depending on your business model for intellectual property concerns, because R is a GPL, which is a viral form of open source. And so this means often this leads to compromises which impact agility. It might encourage people to recode in a new, less analytically broad environment, such as some of the ones that are on the previous slide. Or it might cause you to use some specialized R library that solves one problem really well. But then when you come across the next problem, again, you have to rewrite your R code in order to do that. So all these things got to impact and reduce some of the agility that R promises. So what would an ideal solution look like? An ideal solution would be a single environment that would let you prototype in R, have all that agility for developing new analyses and data prep, but then allow you to deploy to production within the R environment without recoding, without delaying, without compromising, so that you can have an agile response to these sorts of opportunities and threats. And so this would require several things. It would require the analytic flexibility of R on a platform that was highly performant and robust and scalable, something that would be easy to embed into business intelligence and streaming applications, something that would be fully supported so that large organizations would feel comfortable using it for mission-critical applications. But from the perspective of individual R users, it's something that would still allow you to use your favorite environment. Say, work within RStudio to develop your code that you want to then deploy. And that's what we've done at TIBCO. That's the approach we're taking. We call it TIBCO Enterprise Runtime for R, or TERR for short. It's a new enterprise-grade engine we built from the ground up. We could do that because we were the makers of S+. S+ is a closely related environment to R that preceded it, comes from the same root of the S language at Bell Labs. It's designed for R language compatibility with a wide range of built-in analytic methods, compatible with thousands of packages from CRAN, including the most popular ones, things like dplyr and data table. But it's also designed for commercial embeddability. It's something we license and support, and that we can license to partners and customers for embedding in their own products. And the goal of this is really to extend the reach of the R language to the enterprise, so that our users can develop an open source R, deploy on a commercially supported and robust platform without having to rewrite your code, embed this in different applications, and leverage all the existing R ecosystem in things like Hadoop and Spark and whatnot. So I'm going to talk about a couple of different approaches that we've taken here of embedding and integrating the R language into enterprise applications, really in two large buckets, going back to the graph I showed earlier about different ways of getting from data to decision. You can embed R in business intelligence and visualization tools for decision support, for helping someone make a decision. And you can embed it in real-time data streams so that you can automate decisions in response to activities. So starting off with embedding R in business intelligence and visualization applications. How many here are familiar with Spotfire? Okay. Spotfire is a visualization and data discovery tool. It's a complete platform for business users and analysts and engineers and scientists to visualize, explore your data on very, very large data sources. And we make it easy to enhance these analyses in Spotfire with the R language. Directly within Spotfire, you can open up a dialog, you can start scripting in R immediately to enhance your visualizations. And by doing this, you can make your insights that you have in R, the analyses, the scripts, the models that you've developed, and make them directly accessible to a wider audience. Now, one example of this is a dashboard for a retail chain, a grocery store we work with. And this grocery store basically wanted to provide tools to their people who decided to roll out marketing campaigns within their stores. Wanted to provide a tool that helped them maximize sales for different categories. Here is for gift cards, but it could have been any for a number of different categories. And this is a multi-page application that walks someone through analyzing different categories of sales, building different predictive models to determine what's the best model to maximize sales in a given area, and then wrapping it in this sort of what-if interface. And doing what-if in Spotfire is, I think, one of the most powerful applications of advanced analytics and visualization, because it's really helping someone who has the business knowledge, who understands what's going on within an organization, and apply that business knowledge and combined with visualization and advanced analytic capabilities that you can get in R. So in this case, someone can, as highlighted on the left, do some what-if analysis, saying, well, what if we ran this campaign longer? What if it cost a little bit more or less than we think it's going to, et cetera? And really do some optimization around that exploration to say, okay, well, this is the stores you should roll it out to, this is how much revenue lift you can expect on it, and so on. And in terms of embedding R within this sort of dashboard, all you have to do is open up a dialog, cut and paste in your R code, use another dialog that basically tells Spotfire what data to pass in and what to do with the data that comes back out. So it's a simple two-step process that really helps you leverage your R code. And this is all built into the system because of the R engine that we built. You don't have to install and download R separately. You don't have to download and configure R server. You don't have to figure out how to wire things up separately. It's all built into the platform. And so our customers have used this sort of capability to build applications in Spotfire for many different use cases, for things like customer churn, detecting and responding to fraud, optimizing their supply chain and whatnot, and really built some very rich visualization and analytic capabilities in Spotfire using the power of the R language to enhance it. And Spotfire, as I said, can analyze very large data. So in addition to being able to apply advanced analytics to large data, you can visualize data that's in Hadoop, in Spark, in various database systems without pulling the data out. Visualize and explore that data within Spotfire very easily. And then once you've done that exploration, and if you want to pull down some subset of that data for deeper analysis, applying advanced analytics on it, make it easy to do that. And so we talked about one area advanced analytics in visualizations and BI applications. Now we'll talk about R and real-time data streams. So TIBCO's got a long history around event processing, real-time data, streaming analytics. It's gone by several different names over the years. But the general idea is you want to apply some predictive model in real-time stream to some triggering event. So this might be sensors on some industrial equipment that's trending in a bad way. It might be a customer walking into your store or purchasing something from your website. And then in response to that, you want to trigger the right decision using a predictive model. Maybe that decision is to extend a mobile offer to the customer. Maybe it's to stop a fraudulent transaction or to alert the equipment operator or actually shut down the piece of equipment based on the information you're getting from the sensor. We use R within a product called Streambase, which is a streaming analytics product from TIBCO, where you can visually build streams of data, handle that streaming data in various ways, and then leverage these predictive analytics that you've built in R directly within those streams. A couple examples of that. Spotfire is used quite a bit in oil and gas exploration, as well as in predictive maintenance areas. And so we've had a number of customers who use it for predictive maintenance in oil and gas. So in oil and gas extraction, this is very expensive equipment, so any sort of downtime for maintenance or any equipment failures can be very, very costly. And so engineers typically use some ad hoc rules of, well, the pressure's going up, the temperature's going down, I should watch that and perhaps shut down the equipment based on that. And so we've used R to develop some predictive models for predictive maintenance where we can do some deeper analysis, and based on trends in pressure and temperature, we can alert the operator or actually shut down the equipment using the system when the equipment is trending in some bad way, reducing downtime, reducing failures. We're also used quite a bit in transportations and logistics. One of the applications for TERR there is a particularly interesting one, I thought, around maritime abnormality detection, which just means based on the projected plot of where a ship is going and where it's supposed to be going, is it likely to go outside of its designated path? And so in this case, we have a large cargo system cargo company who's using TERR in this way in their real-time systems to send alerts that if their ships look like they're not going to be following the path they're supposed to, or in terms of heading to port, if it looks like the port where they want to dock is going to be full when they get there, the operator can be alerted in order to take some corrective action, can alert the owner about what's going on, can alert the operator to slow down before heading into port, because it's cheaper to get there a little bit later than pay for temporary docking. And we've got a user story on our website around Cargo Smart around some of these details. And so we talked about TERR and the R language in BI applications and in streaming. From the perspective of individual R users, it's important that our R engine TERR is something you can use in your familiar tools. You can use it in RStudio out of the box. You can use it in KNIME as well. KNIME is an open source data workflow tool. It's very popular. And generally, TERR is R for the enterprise. As I said, it's something that allows you to develop in open source R and then deploy on commercially supported and robust platforms without recoding, without compromising, so that you can have all the agility of R and to respond to threats and opportunities, that you can tightly embed and use the R language, and really so that you can take these R skills that you have, that you know how to use R well, you know how to do these analyses, and extend the reach of what you can do with them, rather than handing them off to someone else and having them recoded in another environment. Use the R scripts, the R analyses of the models that you've developed, and deploy those directly into production in a variety of ways. If this sounds interesting, you can learn more and try it yourself. We've got a TERR community page at community.tibco.com talking about Spotfire with predictive analytics as well as TERR. An overview of different ways that you can integrate predictive analytics into Spotfire. In addition to R, we also integrate things like SAS and MATLAB and KNIME. There's a free developer edition of TERR available that you can download and try. You can also get trials of Spotfire and learn more about Spotfire and big data. And that's it. Thank you. we have a few minutes for questions.
Yep.
So, any questions?
Does TERR solve the performance issues of R?
TERR is generally faster than R. And I say generally because you can do a billion different things in both. But TERR is designed to be faster than R. It can be 10 to 100 times faster, especially for things like scoring data. And the fact that it can be easily integrated to multiple platforms means that often you can use other platforms to kind of channel the data to TERR and feed it to TERR in kind of a manageable place. So that was kind of a long-winded answer. Yes. Yes, it's also performance problem.
How do you do a different executable than the open source one? So how do you deal with the CRAN compatibility and making sure that's something runs in one, runs in the other?
So once a week, we download almost 9,000 packages from CRAN. We run tests. We basically extract all the tests from the help files in the CRAN packages. We run in parallel packages through R, through TERR, and compare the outputs. And so we have also the automated testing to kind of alert us when there's some discrepancy, when there's some incompatibility. And then I'm the product manager for TERR. And so it's my job to work with the community and work with customers to prioritize addressing those incompatibilities.
So do they pull from your database, or you just flag things that are compatible?
We generally flag for ourselves things that are incompatible. And then typically most often it might be because we haven't yet gotten to implement some function, or maybe some API has changed in R, and so we'll typically fix that in the next release of TERR. In some cases, we'll work with the package author if that's easier to have them tweak something minor in the package to make it more compatible.
You mentioned if you do data streaming, is that real-time data or is it delayed data?
Real time. Okay, great. Feel free to talk to me after the